Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on exploring and configuring OSPFv2 router IDs. So let's go ahead and read our objective. It says the OSPF router ID is used to uniquely identify each router on the network. Router IDs can be manually configured in OSPF router configuration mode. However, an OSPF router that is not manually configured with a router ID will perform a router ID selection process. In this lab, you will explore how OSPF chooses a router ID. In addition, you will manually configure an OSPF router ID. So if we take a look at our lab topology, we have 3 routers, each connected via a Ethernet cable. And we know that OSPF is a layer 3 protocol. It's actually a routing protocol. So we're going to be dealing with these 3 routers throughout this lab when we're dealing with OSPF. We have 2 layer 2 switches, switch 1 and switch 2. And then we have our PCs down here, okay? So let's go ahead and take a look at the commands that we're going to be using. We have configure terminal, which enters global configuration mode for privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends and exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP OSPF process ID, area ID. This places an interface in a specified OSPF process in area. We have network address, wildcard mask, area ID. This activates OSPF on a specified network and places the matching interface in the specified area. We have router OSPF process ID. This enters router configuration mode for a OSPF process. We have router ID IP address. This configures a 32-bit dotted decimal OSPF router ID. We have show IP interface brief. This displays a summary of interfaces configured on the device. We have show IP OSPF. This displays information about the OSPF process running on the router. We have show IP OSPF interface type number brief. This displays OSPF interface displays OSPF interface information. We have show IP OSPF process ID area ID neighbor. This displays OSPF neighbor information. We have show running config, which displays the active configuration file. Okay, so if we take a look at our IP address table, we can see each device's interfaces, as well as its IP addresses and subnet masks. We would definitely refer back to this table as needed throughout the lab. And we can also see our PC's IP address, subnet mask, and default gateway. All right, so let's go ahead and get into this lab. We're going to keep our lab topology up here in the top left. We're going to be doing our lab readings in the top right. All right, and we're going to be doing all of our configuration down here at the bottom. Okay. So let's go ahead and get into our lab task for this lab. It says task number 1, explore router IP configurations. It says in this task, you will explore how each router is configured in order to predict how OSPF router IDs will be selected after OSPF is configured. So for number 1, it says on router 1, display a summary of the interfaces configured on the router. Based on the output, which IP address do you think OSPF might choose to use for a router ID and why? Okay, so on router 1, we're on router 1 now. Let's do an enable to go into user configuration mode. Let's do a configure terminal to go into global configuration mode. And I could just do an exit actually, because we just need to stay into privilege exec mode. And we could do a show IP interface brief to see the brief summary of all of our interfaces. And if we take a look at this output, and the question was, based on the output, what do you think OSPF would choose for a router ID and why? Well, if we look at this output, we can see that OSPF would choose the loopback 0 interface as the router ID. And that is because this is the highest IP address on a loopback interface. We know that it will choose loopback interfaces if they are configured. OSPF will do that. So OSPF can be stable because we know loopback interfaces are always in the up state. So we do have two loopback interfaces, but it's going to choose the higher IP address of the loopback interfaces. So let's just confirm that is correct. Let's see what Boson is going to say. All right, it says, based on the output, you can submerge that the IP address of 172.16.0.1 will become the OSPF router ID for router 1 if a router ID is not manually configured. This is because OSPF will automatically select the highest IP address on a loopback interface if a router ID is not manually configured on a OSPF router. So yes, that is exactly what I just explained, and that is the loopback 0 interface that I said was going to be selected. So that looks correct. So on number 2, it says on router 2, display summary of interfaces configured on the router. Based on the output, which IP address do you think OSPF might choose to use for a router ID and why? So let's go to router 2 now. All right, we're on router 2. Let's do an enable to go into privilege exec mode, and let's do a show IP interface brief. Okay. Now, if we take a look at this output, we can see that router 2 has a loopback 0 interface with an IP address of all 2s. It's in the upstate, and that is going to be the IP address that OSPF would choose on this router, and that is because it is the only loopback 0 interface. It is the only loopback interface configured on this router, and it's also in the upstate. So we know that OSPF would choose a stable loopback interface because loopback interfaces are always in the upstate, and this will allow OSPF to be in a more stable position, basically. So let's see. I'm going to say 2.2.2.2 would be the router ID that router 2 would choose. Let's see what Boson is going to say. So right here it says, based on the output, you can submerge that OSPF would choose the IP address of all 2s to become the OSPF router ID if a router ID is not manually configured. Only one loopback interface is configured on the router. Although the 2 physical interfaces have higher IP addresses than a loopback 0 interface, OSPF will prefer the IP address assigned to the loopback interface. This is because loopback interfaces are always in the upstate. And it says, this leads stability to the OSPF process running on the router because an interface that is configured with an IP address but in the downstate cannot provide OSPF with a router ID. Physical interfaces can go down for a number of different reasons. So yes, that is exactly what I just explained, and we said that the R2's address would be the one that OSPF would choose, and Boson just confirmed that. Okay, so let's go ahead and move on to number 3. It says on router 3, display a summary of the interfaces configured on the router. Based on the output, which IP address do you think OSPF might choose to use for a router ID and why? So if we go to router 3, all right, let's go enable for privilege exec mode, and let's do a show IP interface brief. And if we take a look at the output, we can see that we have 2 addresses actually configured. We have no loopback interfaces, and we have the Fast Ethernet 00, and we have Fast Ethernet 01. But Fast Ethernet 00 does have a higher IP address than the Fast Ethernet 01, but the Fast Ethernet 00, if we take a look at its status and protocol, it is administratively down. So because this interface is administratively down, OSPF cannot use this actual interface. We will have to enable it to allow OSPF to be able to use this actual interface. So because of that, I am going to say that OSPF is going to choose the Fast Ethernet 01, which has an IP address of 10.10.200.1 because it is in the upstate. Okay, so I'm going with the Fast Ethernet 01. Let's see what Boson is going to say. It says, based on the output, you can submerge that the IP address OSPF will choose to use for a router ID is 10.10.200.1. No loopback interfaces are configured on router 3. In addition, although 10.10.200.1 is lower than the IP address of 203.0.113.6 that is configured on the Fast Ethernet 00 interface, the Fast Ethernet 00 interface is in the administratively down state. Therefore, the IP address configured on that interface is not yet eligible to become the OSPF router ID. And that is exactly what I just explained. And Boson just confirmed that the Fast Ethernet 01, which has an IP address of 10.10.200.1, would be the one that OSPF would choose. Okay? So, on number 4, it says, what change could you make to router 1's configuration to ensure that OSPF automatically chooses a router ID of all ones? So if we go back to router 1, we take a look at this show IP interface brief output. It says, what can we do to ensure that OSPF automatically chooses a router ID of all ones? Well, we could administratively shut down this loopback 0 interface, or we can do a no interface loopback 0 and just completely wipe out this interface, this loopback 0 interface. And then the only one that will be configured is going to be the loopback 1. Or we can go into router configuration mode for OSPF configuration and just manually configure the router ID with a router ID of all ones. So those are the 3 options that comes to mind for me, but let's see what Boson is going to say. It says right here, one change you can make to router 1 to ensure that the OSPF automatically chooses a router ID of all ones will be to remove the loopback 0 interface from the configuration by either manually shutting down the interface or issuing the no interface loopback 0 command from global configuration mode. Either of these options would prevent OSPF from selecting the loopback 0 interface's IP address of 172.16.0.1 as the router ID. And that is what I just explained. Let's also see what it's going to say. It says, if you do not want OSPF to automatically configure a router ID based on the available IP addresses, you could also manually configure a router ID for the OSPF process by issuing the router ID IP address command in OSPF router configuration mode. And I also explained that one as well. Okay, so that is task 1. Let's go ahead and move on to task number 2. It says configure and verify OSPF version 2. It says in this task, you will configure OSPF version 2 on router 1, router 2, and router 3. You will also verify the configuration, including the selection of router IDs. Okay, so it says for number 1, on router 1, place the router into OSPF router configuration mode and configure it to advertise the 203.0.113.0/29 network in area 0. Use a process ID of 10. Okay, so we're on router 1 already. So let's do a configure terminal to go into global configuration mode. Let's do a router OSPF with a process ID of 10 and hit enter there to go into router configuration mode for the OSPF process of 10. Let's do a network of 203.0.113.0, and it wants us to do a /29. So we know the wildcard mask will be 0.0.0.7, and we want to do it in area 0. Okay, and let's hit enter there. That looks good. All right, so on number 2, it says on router 1, display information about the OSPF processes running on the router. What did OSPF select for a router ID and why did it choose that? All right, so if I do an N on router 1 and I do a show IP OSPF, we can see that the router ID that it chose was 172.16.0.1. We can see routing process OSPF 10 with an ID of 172.16.0.1. And it chose this because, as we explained earlier, this is the highest IP address that is configured for a loopback interface on router 1. Okay? All right, so let's see what Boson is going to say. Let's just confirm that. Well, we know the router ID is 172.16.0.1, and Boson says this is because it is the highest IP address configured on router 1's loopback interfaces. Neither the loopback 0 interface nor the loopback 1 interface on router 1 needs to be configured to participate in OSPF for OSPF to select a router ID based on the IP addresses configured on those interfaces. So yes, that is correct. So number 3, it says on router 2, place the router into OSPF router configuration mode and configure it to use a router ID of all 2s. Use a process ID of 20. So if I go to router 2, and I do a configure terminal, and I do a router OSPF20, hit enter. All right, and we want to do a router dash ID of 2.2.2.2. All right, and so let's hit enter there to configure the router ID of all 2s. Now on number 4, it says on router 2, configure each router interface to operate in OSPF process 20 and advertise its network in area 0. As you configure the interfaces, you should see router 2 establish an adjacency with router 1. Okay, so let's do an exit because we're going to be doing all of the interfaces that are configured. So we want to do it in interface configuration mode. So let's go into interface configuration mode. Let's do interface dash Ethernet 00. It's the first one we're going to do. We want to do an IP OSPF for process ID of 20, and we want to place it into area 0. All right, let's say enter there. Let's do an exit. Let's go into interface for fast Ethernet 01X 01. Let's do an IP OSPF process ID of 20 for area 0. And let's do an exit. And lastly, let's do interface loopback 0. And let's do a IP OSPF for process ID of 20. And we want to place it into area 0 as well. And as we were doing that command, we see that we formed our adjacency with router 1, and we can tell this is router 1 by the IP address that is provided. It says 172.16.0.1, and if you remember, that is the router ID of router number 1 right here. So we see that we formed an adjacency between router 1 and router 2. Okay, so that looks good. So number 5, it says on router 2, display information about the OSPF processes running on the router. What router ID is OSPF using to identify router 2 and why? Well, it should be using the router ID that we configured, which is all 2s, but let's just confirm that. Let's do a end. Let's do a show IP OSPF. And yes, if we look at the output, we can see routing process OSPF 20 with an ID of all 2s. And it chose this because, first off, we configured the router ID. And even if we didn't, the loopback 0 interface is the only loopback interface configured on router 2. And it is in the upstate. And as we know, OSPF will use a loopback interface before it uses a physical interface because loopback interfaces are always in the upstate. Okay? All right. So let's go ahead and move on to number 6. It says on router 3, place the router into OSPF router configuration mode and configure it to advertise both the 203.0.113.4/30 network and the 10.10.200.0/24 network in OSPF area 0. Use a process ID of 30. After you configure the networks, does router 3 form an adjacency with router 1? All right, so let's go to router 3 first. All right, let's do a configure terminal. Let's do a router OSPF for process ID of 30. Say enter there. Let's do a network of 203. Excuse me, 203. You can take that one out. 203. There we go. .0.113.4. And we want to do a /30, so that will be O.0.0.3 for area 0. Okay, that looks good. Just wanted to make sure looks good. Let's do a network of 10.10.200.0, and we want to do a /24. So let's do O.0.0.255. Let's do area 0 there. Let's hit enter. All right, and it says after you configure the networks, does router 3 form an adjacency with router 1? And we do not see an adjacency coming up with router 1. And I believe that is because this interface right here is in the down state. 203.0.113.6 is the interface on router 3 that connects up to router 1. We can confirm that if we go to the IP address table, we can see that the fast Ethernet 00 on router 1 is 203.0.113.5, and 203.0.113.6 is router 3's fast Ethernet 00 interface. So yes, that is the reason why we do not have an adjacency between router 1 and router 3. Router 3's fast Ethernet 00, which is the one that connects up to router 1, is administratively down, okay? All right. So on number 7, it says on router 3, display information about the OSPF processes running on the router. What router ID is OSPF using to identify router 3 and why? So if we go to router 3, we're already here. Let's do an N and let's do a show IP OSPF. And if we take a look, we can see that the router ID that router 3 chose was 10.10.200.1. And that is because it would have chose the fast Ethernet 00 interface because it has a higher IP address. But as we mentioned previously, this interface is administratively shut down. So OSPF cannot use this interface as the router ID. So next, it went on to the fast Ethernet 01 and it is administratively up. So it chose this IP address of 10.10.200.1 to be the router IP address, okay? And we do not have any loopback interfaces on this router, so that is out. That is not an option either, okay? So on number 8, it says on router 1, manually configure a router ID of all ones, and then display the OSPF processes running on the router. Did the router ID in use by OSPF change? So let's go to router 1. All right, go to router 1. We're here now. Let's do a tab to get out of that. Let's do a configure terminal. All right, let's do some. All right, let's do a configure terminal, and let's do a router OSPF. And the process ID that we did for router 1 should have been 10, but I just wanted to confirm. Yep, so process ID of 10. All right, and let's do router dash ID of 1.1.1.1. All right, and let's say enter there. And now let's do a end again, and let's do a show IP OSPF. And as we can see, we still have the same router ID, which is 172.16.0.1, even though we manually configured the router ID of all ones. And that is because once OSPF chooses the router ID, we have to either reload the router or we have to clear the OSPF process in order for this router ID to take effect. All right, so that is why this change has not occurred. We would have to reload the router, or we have to clear IP OSPF process. And you can see the output shows us that on this device as well. It says reload or use clear IP OSPF process command for this to take effect. All right, so number 9 says on router 1, issue the clear IP OSPF process command in privilege exec mode. What effect should this command have on router 1's OSPF process? So let's do a clear IP OSPF process. Say enter there. It says reset OSPF process. We want to do that, so let's type in yes. And as we can see, our neighborship went down, and that is because we just restarted the OSPF process. It should come up here in the next couple of seconds after we let it go through all of the OSPF stages. So it should come up here in the next couple of seconds. Let's go ahead and read number 10. It says on router 1, display the OSPF process running on the router. Has the router ID changed? All right, so let's check it now because we've seen that our adjacency came back up with router 2. So we should be in a stable state for OSPF. So let's do a show IP OSPF. And now we can see that our router ID has changed to all ones. So that looks good. All right. So on number 11, it says on router 3, manually configure a router ID of all threes, clear the OSPF router process, and enable the fast Ethernet 00 interface. What message appears on router 3's console after the network converges and why? So let's go ahead and move on to router 3. All right, let's do a tab. Let's do a configure terminal. Let's do a router OSPF with a process ID of 30 because we're on router 3. That is the process ID that we did on router 3. And let's do a router dash ID of 3.3.3.3. Say enter there. And let's do a N to clear. Let's do a clear IP OSPF process. And reset OSPF process. Yes, we want to do that. All right. Now let's do a configure terminal. Conf T. Let's go into interface configuration mode for fast Ethernet 00. And let's do a no shut to bring that interface up. And we can see the line protocol is now in the up state. And we should see an adjacency come up here in the next couple of seconds for OSPF. Let's give it some time. Let's do a N. Let's do a show IP OSPF neighbor. We're in a two-way state, so let's give it a little bit more time. In two-way state. Still in the two-way state. Let's do a show IP interface brief. We should see, okay, I was about to say, we should have seen that adjacency, and we just seen the adjacency come up. So now we can see that we're in the full state. All righty, looks good. So that is the message that should have appeared after the network converges. We see that we now have an adjacency with router 1, and we can tell that by this IP address, which is the router ID of router 1. And it says, why do we have this? And that is because we enabled the fast Ethernet 00 interface, which is the connection up to router 1. So now they can communicate via OSPF, and now the neighborship or the adjacency has came up. All right. So now it says number 12, it says on router 3, display information about the OSPF routing process. What router ID does OSPF use for router 3 now? And it should use the R3's router ID because we manually configured that. But let's just confirm that. Let's do a show IP OSPF. And yes, we can see right here that the router ID that was chosen was R3's. And that is because we manually configured that right here in the output. If we come up, we manually configured the router ID right here on router 3. So this looks to be the end of this lab. So let's go ahead and hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this video, and I'll see you in the next one.